we'll do a deep dive on tag-based service maps of Kubernetes infrastructure and how to make them look as nice as possible. So let's walk through kind of why we're here and what's the goal. Why did Will and I decide to start this whole process? So really the goal of this is to bring together customers in the ServiceNow ecosystem that are all kind of in the same spot in the cloud native journey, to talk about how we're doing things and what's working well together, and to really get some kind of best practices out there, because there's just not enough conversation about this going on. So who we are, right? Mike Gallagher. I am the Enterprise Application Platforms Manager at DRW. I have been, I lovingly joke that if it has a 1 or a 0, I have probably managed it at some point in my career. But really, right now I'm focused in pretty heavily on Kubernetes and automation and just kind of general nerdy things. And today, I am going to be drinking, if you can see this, it is called a Dark Abyss Black Kolsch style ale, which, like, little plug, I got this from the Lazy Dog Beer Club, where they like deliver you like packs of different beers. It's actually really cool. So yeah, Dark Abyss. We'll go ahead.
Hi, everybody. Will Hallam. I'm an advisory solution architect at ServiceNow. I spent most of my 30 plus years in IT working as a practitioner. Spent 6 years as a ServiceNow customer before coming over to ServiceNow about 2 years ago. Really heavily focused on automation, especially in the cloud native space, and been doing a lot of things with Kubernetes and serverless cloud resources. And that's what's that played a large part in leading me to play around with tag-based service maps and come up with the topic for today's session. So during the session, I will be drinking Spare Parts Hazy IPA from Crossroads Brewing Company. Okay, so kind of diving into today's topic. ServiceNow can really do a lot of deep discovery of services that are running in a traditional, on-prem, or even, where it's hosted doesn't matter so much as what it's hosted on. If something's hosted on traditional servers, Windows, Linux, rack and stack load balancers, that kind of thing, our discovery mechanisms are really great at enumerating all the TCP connections that are connecting those disparate pieces of IT kit. And then from that, especially given our new Service Mapping Plus offering, which feeds all of that into a machine learning engine, we can elicit a lot of insights into what quote unquote services, what kind of groups of IT assets are talking to each other and offering up some piece of functionality. Unfortunately, when you're in a cloud native environment, and that's things like, cloud databases, cloud functions, certainly Kubernetes, you don't have that same access where you can just establish an SSH session or a PowerShell session to a server and list all the processes, list all the TCP connections, and then kind of follow the chain from there. You have a lot less of that visibility. Most of what you can see is in the form of metadata, either via Kubernetes API calls or cloud provider API calls. The quality or the type of data you're pulling in just isn't the same. And that presents a challenge for both our horizontal discovery mechanisms as well as top-down discovery, which is our kind of heavily automated and very detail-rich process of mapping a service or multiple services. A solution to that challenge is relying on the tag metadata that resides inside our public cloud resources, inside our Kubernetes clusters. And at a high level, just to kind of, level set people on what tag-based service mapping does, it starts by collecting tag keys, or so when we say tags in cloud parlance like AWS and Azure, those are literally called tags. In Kubernetes, they're actually called labels. And so when we're talking about in this kind of discussion, when we say tags, we're referring to either public cloud established tag metadata or labels within a Kubernetes cluster. So the first thing we do is collect those common tag keys, which are present within the environment, and pull them together into ServiceNow tag categories. And the reason for that is to basically account for the fact that no environment is clean. And when you started out, you may have established, we're going to have an app tag, APP, and that's going to point to what the application is for this piece of cloud compute. And then 6 months down the road, perhaps somebody said, we really should call that app code. And so then resources that were created from that point forward got a tag named app code. But at the end of the day, they're both telling you the same thing. They're both providing the value side of that key value pair is telling you the same thing. And we provide tag categories as a way to pull those together, to normalize those without having to go through and boil the ocean and modify things on the tag side if you don't want to. So once we've got our tag categories, we pull those into what's called service families. And a service family is an expression of what tags you want to concatenate together in what order to then generate a service name. And we'll be running through a couple examples of this to make it easier to visualize after we kind of go through the high level bullet points. Once we've got those in place, the instance will, on a routine basis, or it can be triggered manually, it will scan through all CIs for those matching the layout of tag keys that you establish in your service families. And it'll present you with tag-based service candidates, which you can then select and say, yes, I want to map those. That allows you to kind of onboard new application services at your own pace. It also lets you filter out any kind of noise or, aberrations that maybe match the naming convention, but for whatever reason aren't actual bona fide services. It doesn't kind of open the floodgate and pull them all in. That's completely controlled by the by you. Once candidates are promoted to a full-fledged service, then the instance performs what's called a calculation, where it essentially does what's on this next slide. So it reads a table called service traversal rules to it basically pulls them into a hash. And based on those rules, which say which relationships between what CI classes you're interested in, it will basically draw spans within a service map between those two parent and child CI classes. And it does just that by looping through each relationship that's in the CMDB rel CI table corresponding to those config items. So what that means is, for something like Kubernetes cluster, where you've got a fairly robust Kubernetes discovery pattern, which is establishing relationships between things like pods and containers, deployments and replica sets and pods, where that hierarchy already exists. In order to kind of instantiate that in a service map, all you have to do is pick and choose which traversal rules you want to focus on, which ones are important to you. And that can allow you to have some control over the appearance of your service map. And then as kind of a backstop, after it runs through that loop, if it encounters or if it's got configuration items which don't relate to some other configuration item within that list of IT objects that fall into that service, it just ties them back to the root service. And this is a great start. It allows you to take data that's already in your environment in many cases, because most companies have some type of tag governance around their cloud native items, because that's a key way to kind of to make sense of them, to sort them out and say, you know, how many containers are running that have this app tag on them, or how many Lambda functions contribute to this application service. And so in many cases, this is data that's already out there, and this is a way to leverage that and get even more value out of it by pulling those things together and creating application services within your instance. And then when you do that, you've got the benefit of answering the question, why do I care, when somebody wants to do a change record against a Lambda function or against a Kubernetes node. They can very clearly draw the line between that kind of ephemeral IT piece of IT kit to all the way to an actual business service, because the application service is what gives you that kind of connective tissue between pieces of IT stuff and some kind of business value or user-facing functionality. So it's a great start. The one kind of challenge is that especially if you've seen a top-down service map, the service maps that come from tag-based service mapping by default tend to be kind of flat. They don't tend to arrange the stuff in tiers that give you an idea, okay, this is kind of the primary endpoint that's getting hit. And then from there, it tends, the dependency or the data, the interaction flows to this set of things, like a load balancer, and then to this set of things, which is potentially some app server containers or cloud functions. And so what we'll kind of talk about is how to take that next step and add some more visual enrichment to the maps that you get out of the box. So this is just an example of Kubernetes application, and what you get just out of the box without doing anything other than saying, hey, I want to pull a couple tag values together and generate a service from them. So the top up here is the app service entry point itself, and then it branches out into the various kind of second tier Kubernetes objects. And this would be things like a Kubernetes service, basically, the record that defines what port or ports are being listened to, whether it's behind a load balancer or a cluster IP. Deployments, pods, replica sets, daemon sets, stateful sets, they all end up kind of in this middle row. And then the one dependency that kind of the downstream reflection that you get out of the box is where it ties a pod, such as this Redis cart pod, to the containers that are within. In this case, I've got an Istio proxy sidecar and the actual Redis container image itself. And it's the utility there is still pretty good, because it's ultimately still collecting all of those things into an application service, which then can be referenced by things like incidents or changes, and identify that kind of spider web effect where you say, well, I'm going to touch the pet clinic service, and you can see, oh, under the covers, it's going to spread out into all of these Kubernetes items. So for example, these are, things we would want to mute in the monitoring system while this change is going on to make sure that we're not getting false alerts. Or if you're using event management could handle that for you by detecting, there's downtime records lodged against all of these CIs. So we know not to run any kind of escalations if we get events in during that change window. Similarly, with an incident record, somebody says, hey, pet clinic's down. This would immediately say, well, here's a list of everything that comprises pet clinics. So here's what you need to look at. Whoops. Jump.
Another important thing to call out there is this more closely resembles the model of the data model that Kubernetes uses internally, right? Once you build out this tag-based service map initially, right, it doesn't really bear much resemblance to the data model and the relationships within the components within Kubernetes. Once you go through and do this process, it looks much more like what a standard Kubernetes operator would expect to see in how the components are laid out.
That's true. And it, because it's configurable, if there's specific conventions where you kind of want to have a certain set of precedents between how that top-down appearance looks, you'll see that can be tailored with using these mechanisms. So at a high level, the way we do this is depending on what the configuration items are, we may or may not go into the CMDB rel CI table and add additional relationships.
I had one quick question. Sorry. Well,
no, go ahead.
So like one of the things like we do is from a cluster standpoint, it's provided as a service. So we'll say Kubernetes is a service, right? And the clusters are owned by one group, but the nodes themselves underneath it, or at least the kind of member servers, are owned maybe by the same group or a different group. Mm-hmm. But then the VIPs or the virtual IPs or the load balancer or cluster piece may be owned by a different group. Mm-hmm. And so are you able to tag some resources, but it doesn't necessarily include their parent resources as that same service map, or would it automatically, if you said a node belongs to one group, it would automatically assign that cluster to the same service?
No, it's granular. You can split it up that way. One of the things I've seen in the CSDM white paper that talks to that kind of to a certain degree, like in other words, where you'll have like one team that kind of owns the infrastructure piece, and then you'll have one or more app teams that own the actual workloads that are running within. One of the things that sometimes works is you can actually use a CI group to tie together things like Kubernetes nodes, and then have that, because that's another valid way to define a service is via a CI group, which just the advantage to that is as soon as that CI shows up that matches your filter, then it immediately gets pulled into that service. Okay. There's pretty good. It's fairly granular, and you can when we kind of jump into the instance, and I'll point out where you can actually you can also say, like, even if you want to use tags for that, for example, like if you tag a node with or label a node or a cluster with, oh, this is supported by team A, then you can actually break out and have a specific app family, service family that ties to not just the kind of support team tag, but only the ones where the value is team A. And then you can have a second one for team B. So that's an option as well.
Because part of what the problem we have is when we get vulnerability assignments, when they come through, we need to understand who owns what's running, right, on the node, less so much about who owns the node and is managing it as an infrastructure. So,
Yep.
Okay, awesome. Thanks.
So adding or adjusting relationships, that's optional depending on the type of asset, the type of resources you're talking about. Kubernetes has the Kubernetes pattern throws in a bunch of relationships where and we'll take a look at a dependency view to kind of illustrate that. So if you've already got a bunch of relationships and you just want to reflect that in your service map, then you can kind of skip to the second step, which is just add traversal rules. And that's where you pick and choose. I want to see the relationship between a Kubernetes deployment and the pods that it is responsible for, that it provisions. You add a rule that corresponds to that, and you'll get those lines drawn in your service map. And we'll show you that in a minute. Really important. By default, for whatever reason, probably just to be conservative on performance, when these maps are being calculated, there's this property, service by tags, max traversal rules active, is set to 5 by default. And you'd most likely want or need to increase that if you're going to kind of build out this capability beyond what you get by default. I think there's 3 rules that when I just fresh, pristine system got it provisioned, there were 3 rules that were set to active. And so you're going to run out of runway real quick if you don't boost that that property. And then kind of after you've set the table, the way you put it into action, the way you make it take effect is that recalculate service related link that's on the tag-based app service record page. And so here's an example of what happens when you add some additional traversal rules and or some relationships. And I'll click through the live version of this, but it just provides a more kind of visually pleasing and illustrative service map, as opposed to kind of putting everything across that middle tier and then only branching down to show you the underlying containers that are running inside. Because ultimately, we get a lot of feedback that people don't really care about how many containers there are or even how many pods there are. They're really concerned about, the operator structures that are in the cluster and telling it to spin up this application or this microservice. And that really speaks to kind of these top tiers, where the way this is currently set up, and it's not strictly dependency based, it's more kind of conceptual flow of data based. So it goes from the application entry point down to the service. So that's, the ports that that particular service is listening on. And then it goes down to the deployment, which ultimately, service isn't talking to the deployment, but it's just a downstream flow where the service is going to talk to the pods, which are ultimately controlled, the provisioning of which and the restarting of which, the migration of which, all that stuff is determined by this deployment. And then in between the deployment and the pod is the set. So I'm not sure off the top of my head if this is a replica set, daemon set, staple set, but whatever that is in ServiceNow parlance, that all falls under the Kubernetes workload table. Whatever that is, that's kind of the downstream product or artifact out of the deployment. Okay, so now some live examples of that. So just to kind of quickly level set, here's the record for an example Kubernetes service. And what I did to kind of prepare this environment was I took an example Kubernetes-based application and I applied some labels to it. And those are reflected down here in the key values related list. And we discover this for all the public cloud stuff, all the Kubernetes stuff. Pretty sure even VMware has tags that we can pull in as well. So if you're running discovery in those kinds of environments, you've got all of this tag data in your instance already. And all we're doing is just focusing in on the bits that kind of tell the story of this is the application environment geography that ties all of these like components or kind of like purposed components together. So in this example, I defined in the Kubernetes example, I kind of homed in on this key value here, which I called service, and this key value here, which ties back to an environment designation. So this is my make-believe QA environment for the boutique application. The reason I kind of broke out, I named this service, was just because it just so happened that this example set of Kubernetes manifests already had an app tag, but it used that for kind of the microservice level. And while you can certainly, map out each microservice into kind of a mini map and then tie those together with dependencies, it doesn't, you have to kind of click between them. It doesn't really produce that kind of visually meaningful, here's everything that rolls up to this kind of larger primary service, which is called boutique. And so that was why I chose to do that. But the good news is it's completely up to you. Whatever kind of tag taxonomy you want to put in place, you can use it, and all of this functionality will work exactly the same. So picture, if you will, I've got a whole lot of Kubernetes pieces that make up this boutique service, this boutique application. And I've just applied these common tag values. And we do get asked a lot, what are, greenfield, what tags should I put on my stuff that lend itself to effective tag-based service maps? The top two are definitely application or some kind of an app code. A lot of places have, portfolio management, where when a new application or service gets onboarded, it gets assigned a unique code. So that's also, something that categorizes, describes the application or the functionality which is being provided by this group of stuff. And then environment is definitely kind of the second most common thing that gets called out. It's ubiquitous. There's I don't think there's ever been anybody I've talked to who doesn't have at least a prod and one or more non-prod environments, right? I mean, there's always that's just kind of a ingrained separation that we do as IT practitioners. And so the concept of having an environment tag is extremely prevalent. And then on top of that, I would say the third most common tag key is geography, and by that, not necessarily like country or state, but if you've got multiple campuses or multiple data centers, codes that, some type of a code or designation that ties things to one of whichever location type paradigm is being used. Okay, so I've got all this Kubernetes stuff, and it's all got similar tags set up. And so just to really quick walk through what I kind of covered on the slides.
Just to jump in really quick there, I also see in cases where things are being automatically provisioned, requester or owner are also kind of similar tags that we see. But that's more in the case of like, hey, we're automatically provisioning all of these components and we know who is requesting this or who is the owner at the outset. Sorry, continue.
No worries. There's a lot of diversity there, and there's kind of no limitation. I think there is a property that defines like the maximum number of tag categories that you can concatenate together. I think that's also set to 5 by default. I would say just from a cleanliness perspective and a length perspective, that's probably not a bad shout for most shops, but you can tweak that if you need to concatenate, 6 or 7 tag values together for whatever reason. So as I mentioned, in reviewing this, when we were reviewing the slides, the tag category just provides a way to normalize your tag keys without having to remediate your actual tag metadata. And not that ServiceNow can't help you do that as well. We've got a great offering with tag governance, but we're not, there's no requirement that you have normalized or standardized tag keys. If you've got a few variations, this is where you implement those. So if you've got app and also application as a tag key that ultimately ties back to which application a piece of cloud native stuff maps back to, you just capture that all here. And so I've got one that ties back to something called app. Oops, I guess I should save. I don't need to save that. That was just for instancing. So we've got a couple other ones, and the tag category name is really just the handle by which ServiceNow knows that list of tag keys. So here's where I define my environment tag key. And then I did the same thing for that service tag key here. And so once I do that, I assemble those into tag-based service families. And so for my Kubernetes-based example, I'm saying, take the value of my service tag, and you can specify the order that they get concatenated by the service naming order value here. So I'm saying, take the service label and take the environment label, concatenate them together. The standard delimiter is a double colon, as you can see by this one map service that it lists down here. Once you create the service, and so you can also specify specific tag values. So this would be where, if you had a support group label and you wanted to pull, just a list of all the app services together into a family that were supported by a given team, that would be how you did that. You would have this, BX service dash team A, and then you would say, support team as the tag category here. And then you would say, here are the values that I want to filter on. And again, these are all just records. So you can also, if you've got like an Excel workbook that ties, like standard tag values to standard, support teams or, whatever, financial hierarchies, you could write a flow and just ingest that and generate these tag-based service families accordingly. So if I was setting this up for the first time, and if I didn't want to wait for the scheduled job that runs once a day to generate service candidates, I could click this link here to manually update service candidates. And then I could click this button here to view those service candidates. And in this case, the only candidate has already been mapped, so I don't see any candidates. But if I had any candidates which hadn't already been accepted as a service, they would show up here. Excuse me. And then there's a checkbox and a UI action down at the bottom that will instantiate saying map these services. And that's how they end up in this related list down here. And then I can click view map, and it will show me the map that was generated. And if I'm on a vanilla system, this is the kind of thing that I would get. It's basically, let me go to the boutique. This is just a live version of what I had in that one slide. It's going to be fairly flat. It's going to take all of the different Kubernetes parts except for the containers and place them in a kind of a middle tier of Kubernetes objects. So for example, this here is the service. This is also a service. This will be the pod. And so it's good in that it's collecting everything, and you'll be able to use it to assess impact on changes in incidents or alerts. But it's not as visually pleasing as if you could get a visualization like this. And in the context of Kubernetes, all it's doing, if I look at a dependency view, is it's just kind of mining these existing dependencies, which are already sitting in your CMDB if you're discovering your Kubernetes clusters.
And that flatter map is much harder to read, right? And it doesn't, again, like I was mentioning earlier, it doesn't really follow the Kubernetes kind of object hierarchy. Whereas the more customized tag-based map does.
So I've always found dependency maps to be kind of cool and kind of take them or leave them, in that it's definitely cool to see this kind of spider web effect of all the dependencies that are present in your, in your IT estate. But at the same time, it's just too busy. You can't make sense of it. It's really just a good illustration of here's all the relationships that we're gathering under the covers behind the scenes. But it's really with service maps where you could kind of distill out the pieces that you're predominantly interested in. And so that's, I think, a big part of the value statement behind service maps like this, where you can basically say, okay, we've got the boutique. It relies on all these microservices. And, especially in this case, where we've got both an external and an internal service endpoint for the front end. That's, kind of useful to know when you're talking about planning changes. Perhaps, you're touching an external load balancer, and you need to know that you're going to have to validate external traffic as well as internal traffic as part of your kind of change validation plan. And so how did I do this? It all comes down to in the space of Kubernetes, in the context of Kubernetes, it's all done via traversal rules. And so if I clean up this traversal rule list to just show what's active, and then I filter just on Kubernetes stuff. And so by way of comparison, let me go to a vanilla system and just show you what you've got out of the box. Filter out. Okay, so out of the box, you have 3 traversal rules. One ties hardware back to a VM. One ties an application back to a hardware record, and then one ties a Kubernetes pod back to the container. And that's why when we look at the vanilla Kubernetes-based map, Kubernetes tag-based map, we see that, it does break out the containers running inside the pod. So what I created, I just added 3 rules. One rule that ties a Kubernetes service back to the deployment. And this is an existing relationship that the pattern provides. So I didn't have to go in and tweak any relationships. I just discovered my Kubernetes cluster and added that rule. Then I added a rule saying, hey, when I see a Kubernetes deployment, which owns anything in the workload table. So workload is stateful set, daemon set, replica set, and anything else Kubernetes comes up with. They seem to come up with new operators or new set types all the time. And then kind of the bottom tier that ties that set to the pods is accomplished via this rule here, which says anything in the workload table that has an instantiated by relationship with a pod, I want you to draw a line to reflect that. And so we do have the ability when creating these rules to reverse them. And so the best way I can describe the reverse option when you're doing traversal rules is if the object that you're seeing in your flat map is actually the child, then you need to hit reverse in order for it to pull the parent into the map. So what I was seeing, for example, was if I created a rule that tied a pod to a deployment without setting that reverse to true, it wasn't connecting them. It was leaving them kind of on the same level in the map. And so the kind of black boxing it and changing, tweaking rules and seeing what it does. That's my best explanation of what that reverse flag is used for. It's kind of used to bring, if the thing you're trying to bring to the foreground is in the parent position and you're already seeing the child in your map as it is, then you set that to reverse, and that kind of locks them together and creates that kind of waterfall appearance where they kind of flow down from top to bottom. So the other example that kind of speaks a little bit to when you don't have the relationships already pre-baked into your discovery pattern is if you've got, for example, a cloud-based application which uses cloud functions, a cloud load balancer, a cloud database on the back end, perhaps, then what you get out of the box with that is going to be something like this. So in this case, I've got some AWS components that are tied together by common tags. Basically, an AWS load balancer over here, which then ties into a couple Lambda functions, which are these two guys here. And then the Lambda functions are using an AWS RDS instance, cloud database, as the back end. And so out of the box, what you get looks like this. It's all very flat. These other items are just, these are RDS snapshots that are automatically taken by AWS of the cloud database. So it's kind of pulling those in as part of the application since they live on that database instance, which is tagged as part of this pet clinic QA environment. And so when I look at the dependency view for this kind of stuff, it doesn't really capture any relationship by default between the database and those Lambda functions, other than they live in the same AWS account. So if I look at the cloud database here, it's got a lot of relationships, but it's contained in this availability zone. This relationship talks about, it's contained in this, it's going off the screen. It's probably cloud service account there. It owns this IP address here. Anyway, there's not a lot of useful out-of-the-box relationships in there that we can capture and use for a service map. So what I did in that case was I created a little scoped app, which I call tag enhancement. And I just generated a JSON file for each of my apps. And I just spelled out, here's the relationships that I want to establish between the different pieces of my application. And so the idea here is, if it's an internal application that's a cloud native construct, it's probably going to be built via some CI/CD pipeline. You can capture the relationships between the different components in a JSON, a YAML file, whatever, as part of your CI/CD process. And then whenever you build or do a build or an update, you can feed that into your ServiceNow instance. And in my case, what I did was I just created a quick table, and I just uploaded that JSON file as an attachment. So I could just do a little demonstration flow like this that just goes through, it parses that JSON file, and it establishes those relationship records inside the CMDB CI relation table. And then because I've done that, when I look at my map on my enhanced ServiceNow instance, I should see a little more layering that kind of shows a more visually impactful depiction of what this cloud native service is doing. And so this is that same service, but you can see now it's a lot more hierarchical. I've gone from my entry point. I've still got my RDS snapshots here off to the side, which is fine. But here's my load balancer. It's talking to the two Lambdas, and they're talking to this backend cloud database.
Couldn't you potentially also create a traversal rule to tie those snapshots to the RDS database?
Yes. Yes. So what I did, I did have to create some traversal rules. Just two. I created one saying, hey, if I see a load balancer connecting to a cloud function, I want to know about that in my service map. If I see a cloud function connecting to a database, I want to know about that in my service map. One piece of errata, or just something to watch out for, I've been working to try and get cloud functions to have multiple levels. And by that, I mean, ideally, I would want this front end function to be kind of on its own level, and then cart function to kind of be down underneath that, because in my imaginary pet clinic application, everything flows through the front end, and then underneath that, it would have things like the cart service, the currency conversion service, the order status service, that kind of thing. I haven't quite figured that out yet, so stay tuned. If I figure it out before we send the wrap-up notes, I'll certainly make a note in there, or I'll do a community post once I finally kind of get that nailed down. So I did kind of what I would have thought would have caused that behavior. In other words, I created a relationship between front end and cart, and then I created a traversal rule saying if a cloud function depends on used by a cloud function, then I want to know about that. But somewhere in there, the calculation doesn't seem to pick that up, and I end up having, the cloud function, the dependent cloud function ends up kind of up at this top tier with the snapshots right now. So more to come on that as I kind of make further progress. But other than that, it's been fairly straightforward in kind of pulling these things together. It's really a matter of prioritizing what are the important kind of upstream, downstream tiers that you want to reflect in these service maps to make them more useful than they are just with a kind of a flat topology being depicted.
Hey, Will, I had one other question for you. I was going to say the hierarchical piece is important. We have a similar use case. So if you figure that out, I would definitely like to know about that. The other question I have is, how uniformly is this implemented across the different cloud providers? And so we're kind of hybrid multi-cloud.
Mm-hmm.
And part of the problem we're going to have is whether we can uniformly manage tags across the different cloud platforms, but are you able to distinctly say this applies to AWS in some hopefully easy way versus GCP of how we apply it? And are some things able to be applied across both?
So I've personally played with Azure and AWS so far, and this
Okay.
is basically the same app in Azure. And other than kind of the lack of snapshots being pulled in for the cloud database down here, it looks fairly similar. And that's all with the same set of traversal rules and tag families and tag categories. So at least firsthand within those, between those two providers, I haven't had to make allowances where I do tweaks to kind of deal with the foibles of Azure or AWS. I think if anywhere, the place where you might run into kind of slightly different behavior is in the CI classes. So I did run into a weird thing with cloud databases in Azure, where Azure is migrating away from like their single server cloud databases. Like you can't even provision them with the console anymore. You can do it with a CLI or an API call right now, but they're phasing it out. And so in order to pull this in, which was a flexible server, I did have to kind of go down to the pattern level and kind of adjust something in order for this database to show up. I think that's actually been handled. That particular thing I ran into has been handled by a pattern update. They've just made a big jump. I don't know if anybody's noticed, but they did a fresh drop of the patterns app this month, and it went from version 1.0.99 to 1.3.0. So I'm expecting big things, big improvements in discovery patterns, including, cloud discovery, when I finally get my demo instances updated to that latest store release of the patterns app. But
So maybe there's a way to tell the difference between VMs versus on-prem and cloud and different clouds and tell which type of VM machine instance it is, rather than having to drive it back to a data center to a subscription.
yeah, you should be.
Yeah.
Yeah, you should be able to. I know it does depend a little bit on how you're doing your discovery, because I noticed, for example, like when you go in here, there are some cloud provider specific, views in Filter Navigator. So if you put in AWS, for example, it does kind of break down where you can get individual views, and all these tables are actually kind of general purpose tables. Like storage volumes is not.
Yeah, some of them are still database views where they're doing the lookup behind the scenes, so they're not the VM. You're right, the VM machine instance, right? Table still just has the generic data, and the only way to differentiate those is, like you're saying, is either to use the newly created database view or to figure out to add an attribute or a tag so that you can manage it yourself. But it was a kind of a shortcoming of showing all of those VM instances in that same table without any kind of device type or delineation or attribute of where they came from or which type they were. So yeah. Okay.
Yeah.
I don't mean to derail it. I was just it's one of those things we had run into. So
yeah. Well, and basically I ran into this when I was doing some work with the Service Graph connector for AWS. It doesn't, whatever this view is filtering on, the Service Graph connector didn't populate that attribute. So the first time I ran it, it said it discovered a bunch of VMs, but then I went to this AWS virtual machine instances.
And they're all empty. Yep, that's how we found it. The same exact thing. Yep.
Yeah.
And so then they pointed us to the left nav thing, and then my boss asked a question, and I was like, "Oh, that's a database view, and here's what it's based off of." And even that, because it got weird for one of the other tables isn't populated correctly, and it's putting it into a parent table or a child table, and so even the view by default doesn't work for the at least the older version of the AWS Service Graph connector. So, yeah. Anyway, sorry.
No worries. That's a good opportunity to give a plug for our next session, which is going to cover some updates on the Service Graph connector for AWS. They're going to version 2.0. It's got some major updates, as well as talk about the first iteration of the GCP Service Graph connector. Also, since we're getting close to our official time, and Mike and I generally both just hang out for as long as people want to shoot the you know what, but before we reach the official time, I do want to announce we've just found out that we've been kind of approved and funded and all that stuff to have a live Beers with Engineers session at Knowledge in May. So if anybody's on the fence or was considering not going to Knowledge, please reconsider, so you can join us for some actual live beers and actual live engineers in Vegas in May.
Yeah, count me in. I'll be there.
Nice.
We're excited.
Yep. Awesome.
So as always, this recording, the slides, I'm also going to try and I ran into a little snag because there's some hierarchy in these traversal rules, but I'm sure I can figure out how to pull these traversal rules into an import set just as a useful example, hopefully. Include all those in our wrap-up emails that will come out shortly after, shortly following today's session. At this point, I'll just open it up. I will shut down the recording and then just open it up to open forum, whatever questions or topics people would like to discuss for however long.